Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. The starting material is hex 5YN1-ol, a terminal alkyne with a hydroxyl group at the other end, HCC-CH2-4O. Moving on to the next step. Treatment with H2 with a suitable catalyst, implied to be a full SYN hydrogenation catalyst, reduces the terminal alkyne to a terminal alkene or fully to an alkane. Given the product is to methyl tetrahydropyrin, the alkyne is hydrogenated to give hex 5N1-ol, the alkene intermediate, or more precisely the terminal alkyne is reduced to give CH3, CH is equal to. Wait, let me reconsider. With H2, full hydrogenation, HCC, CH2, 4O becomes CH3, CH2, CH2, 4O is equal to hexane 1-ol. But that cannot cyclase to give a methylated ring. Moving on to the next step. With H2 Lindlar catalyst, partial hydrogenation, the terminal alkyne HCC-CH2, 4O becomes CH2 is equal to CH, CH2, 4O, hex 5N1-ol. Then acid-catalyzed intramolecular cyclization, H+, of the alcohol onto the alkene gives to methyl tetrahydropyrin. The O attacks the double bond, Markovnikov, forming a 6-membered ring. The carbon bearing the methyl group, C2 of the ring, becomes a new stereocenter. And for the final step, the acid-catalyzed cyclization proceeds via a protonated alkene, carbocation or protonated intermediate. The nucleophilic attack of the hydroxyl oxygen on the carbocation can occur from either face of the planar carbocation with equal probability. This generates a new chiral center at C2 of the tetrahydropyrin ring, the carbon-bearing CH3 and O. Since both faces are equally accessible, equal amounts of R and S enantiomers are formed. Equal amounts of R and S enantiomers constitute a racemic mixture. The product has one chiral center, C2 with CH3, OH, and the ring carbons giving 4 different substituents, so it cannot be meso. Both enantiomers are formed in equal amounts, making it a racemic mixture, which is optically inactive as a mixture but each component is optically active. A. Optically active incorrect because equal R and S are produced, cancelling optical rotation. C. Meso, impossible with only one stereocenter. D. Diastereomers, requires at least 2 stereocenters, only one exists here. Therefore, the correct answer is B. Therefore, the correct answer is option B.